Well, thank you very much for coming. So today I'll talk about how our company uses Neo4j graph technology for our competitive intelligence platform. Start with a little bit introduction about our company. So I work for Dupont. So Dupont is a science company. And our mission here is to use science to deliver sustainable, innovative, and market-driven solutions to solve some of the world's greatest challenges. And we aim to make life better, safer, and healthier for everyone. Well, that may sound very abstract. So specifically, what are we doing? Well, first, let me start emphasize that Dupont is a very old company, perhaps one of the oldest in the United States. We started over 200 years ago as a primarily focused on the manufacturing of gunpowders and explosives. So that's what we did for the first century. And then at the beginning, about 100 years ago, we switched into the chemical industry. And we have basically initiated the revolution of chemical manufacturing, especially in the plastics space, with a lot of well-known products such as nylon, Kevlar, Tyvek, that you might be seeing around a lot. And more recently, about 20 years ago, we have, again, diversified our business into other spaces such as health, nutrition and health, industrial biosciences, as well as safety and protection. However, regardless of the specific space, specific industry we're playing in, the core for us is still using science-based solutions to drive innovations to deliver superior products to our customers. At this moment, the main focus of our company are primarily falling into the three pillars as shown here. They're designed to address increasing demands driven by the global population growth. That's including the growing demand in food, growing demand in energy, and also the growing demand related to urbanization and also improving the quality of living. And the approach we take to deliver science-based solution towards a superior product is through collaborations. Because we truly believe that just by ourselves, we won't be able to deliver those solutions fast enough. And we want to be able to access both our internal talents and also talents from all over the world. And the goal is here to connect our 9,000 scientists engineering at Dupont with external researchers globally in universities, startups, national labs, as well as other companies. So to promote more effective collaboration between our scientists engineering with the external researchers, we really needed to have very good, faster and deeper insight in some of the key questions, such as what are the emerging areas and who are the leading researchers, how to identify and connect the state-of-the-art technology with our line of business and specific products. And all of that, we have to do that faster and better than our competitors. So as the corporate information data science team, our goal was to develop such a technology intelligent platform for the entire user base in our company, including scientists, engineering, and business users, to provide such insight for them. So our overarching goal is to be able to ingest a lot of different data from external sources and process them and synthesize some actionable intelligence for the user. And here shows some of the main objectives for the system as we started this journey 3 years ago. What first thing is be able to capture and ingest a lot of technical information from different sources and be able to organize them and integrate them into a knowledge management system. And based on that, to deliver faster and more accurate technical search and data discovery. And finally, is to enable holistic, multi-level, advanced analytics for the user. So the schematic shown on the right side of the slides are showing essentially the process. We want to start with the data and objectize the data into entities such as people, organizations, and based on that, we only extract more in-depth insights such as technology, business, and the strategic level. So now let's get into some of the data sources that we have to deal with in terms of technology intelligence. So here are listed some of the representative data sources that including scientific publication, patents, regulations, government funding, as well as news media and websites. Well, within each category, there are additional subdivisions. For example, there are thousands of publications, scientific journals that are relevant to us. There are over 70 countries of patents and regulatory information we need to keep track of, so as for government grant. And also, we all know there are millions of news media and websites that could potentially be relevant to us. Well, at the beginning, some people ask the question, if we are only interested in gathering this information, can we just use a federated search? Well, the answer is no, because we soon realized that maybe not the publication of the patents, but the relationship between those entities are more important. One example is the people. The common factors between publication, patents, government funding are the people who work on the research, who write the paper, who apply the patents. So that's one key relationship we need to identify and capture. Other examples would be entities and products or chemicals. Those are the factors that we need to identify and then integrate them all together from those different data sources. Well, that imposes a big challenge for us is about data integration. Since we're dealing with such a diversified source of information, we have to put in significant effort to integrate data and also disambiguate the data of information from those sources. And that's where we realize some of the issues with the SQL database that we initially set to use, especially related to the schema, the flexibility. As we are pulling in additional information, it's very hard to set a good schema and then to cope all the diversified information. So that was a big issue when we started using SQL for this purpose. But perhaps the even bigger challenge for us is on the analytics side. Once we have the data in the database, how can we make that available to the user? How can we derive insight? Well, some of the issues is it is increasingly difficult for us to write SQL queries for some of the more open-ended questions, such as who is connected with whom. And sometimes the query just exceed the capability of the database and make the results impossible to obtain. And one last thing, which perhaps is the most important, is writing SQLs are not some inherent capability for our scientists and engineers. So we always know that from the very beginning that once we collect the data, we have to make them available to our end user, who are the domain experts in chemistry, biology, etc., and whatever other specializations. We have to provide the data and let them to play with the data and to do their own analysis. And SQL languages are simply beyond the reach for all the scientists. Well, in searching for the right solution other than SQL, we set our eyes on the emerging graph database about 2 years ago. And after some evaluation, we select Neo4j for this project, mainly for two reasons. One, we liked it because it's a native graph technology, and also we really liked it because it's a very vibrant open source project and has a big community behind it. So we started using Neo4j, the community version Neo4j about 2 years ago. and we really like it. And about 6-9 months ago, we became a customer for the enterprise solution. And here are some of the key benefits of using Neo4j graph database. One is that we realize it's a very natural flow for us to map the different data sources into entities and relationships in a way that's very easy to analyze by our end user. So it's such that it's accessible to the domain experts. And also the graph data schema is very flexible for us to adding new entities, adding new relationships, so that we're not limited in that front. So shown here is a graph, is an example how we can map scientific publications, authors, and patents, and domain spaces into a coherent graph, such that they're all well connected in a way that's very easy to our end user to understand and for them to explore by themselves. So fast forward 2 years, from the beginning of using Neo4j towards where we are now, is we're building this graph-based platform for our corporate level technology intelligence platform. So the left side of the diagram showing a list of different external sources that we're interested, that we get as the input of our database, that including publications, patents, government fundings, as well as other business and data that we gathered from third-party data API providers. And the center of the diagram is the core graph database that we're using to integrate all the different informations together and to objectize them into separate entities to extract the common factors such as people, technology, chemicals, products from those information sources and create such a graph. And finally, on the right side of the graph are showing a list of deliverables that we have, a list of services we have to our end users, including a search engine to allow people to search the existing information, and some alert systems, a dashboard for interactive analysis, as well as reporting and self-service analysis using common BI tools. So this is overall the platform that we have been developing for about 2 years. I'm very excited about this work, and I truly believe that once it's complete, it becomes a really good foundation for our next generation intelligence system. So now let me jump into some examples of how we can use some of the knowledge or insight we derived from the graph database to drive business decisions or technology decisions. Well, one thing we really like is simply just the graph interface for visual analytics. For example, if a researcher pulls a set of documents from the graph database, and they can immediately get this view of how this body of publications are interconnected together. What are the authors? What are the top authors that publish the most paper? How the publications are divided by the technology domains? And also, what are the emerging topics if you factor in the time domain, the time dimension into the graph? So it's really, this could be very simple. We haven't done much other than just pulling the data from the database. Already provide a lot of insight for our end users just to explore. And also, I want to mention the graph traversal capability. You start from one publication, you follow it. The publication is cited by the other publication, and you just follow the chain of order. That's a very natural way for scientists to explore a technology domain, and it can be very easily done using graph database. Well, another thing we do is more along with the cluster analysis to identify collaboration networks. As I mentioned earlier, a strength of graph database is to explore the relationships between the different entities. So we have defined a specific set of relationships, including direct relationships or indirect relationships, that we think are critical to reveal the collaboration nature between university and startups. And we have been using this strategy to help identify the university and startup ecosystems in order for us to identify the good partners. And also, we found this cluster analysis is also a very good way for us to identify white space. In a sense, faster and more accurate than we can do before. Although the Neo4j right now does not have a self-service UI yet, we do find it is possible to integrate with some of the existing BI tools, such as Tableau, and allow the end user to do some self-service analysis, so that the end user is happy that they will be able to access the data and to play with the data to some extent. For example, do some aggregate statistics to find out what are the top industry related to a specific project, what are the top companies related to a specific domain. So just this simple self-service analysis coupled with a standard BI tool has been very useful for our end user. One more example here is about competency benchmark. So once we have all this very sophisticated diagram, including both internal researchers and external researchers, we can develop some metrics to measure competency in specific technology domains. And this can be used in two different ways. One way is to identify our competency gap with regard to the specific project, the specific growth initiative that we have. So we can do some strategic hiring. Another possibility is that we can benchmark ourselves against our competitors, see where the gaps are. And the other way to use it is to identify collaborators who can provide complementary competencies in a way that can really drive us growth. Well, last but not least, the way is to just really ask open-ended questions using Neo4j. This is a very natural way for scientists to do research, is to ask these open-ended questions. What if A is connected to B? What are the connections between C and D? What are the possible ways to apply technology A into application B? So all of this can be very easily implemented using the graph query language, and therefore can immediately get insight very quickly and efficiently. Just some examples with regard to this topic. As our company is a very diverse portfolio, some of the things we do can really enable a hybrid technology growth to apply technology in one domain into an application space in another domain. So this tool has been really helpful in that regard. Well, that is what we are at this moment. And for the next step, what do we aim to do, including expanding our knowledge base to incorporate internal technology data? Well, that's something that was not possible when we're using the community version of Neo4j due to the lack of access control and security, which are required by our corporate security information office, which also is the main reason we adopt the enterprise version. The next big thing we want to do is enable our end users, who are the scientists engineering, to incorporate their personal knowledge and also their personal insight into the graph. So can really make additional connections, relationships that's than what's existing in the external data sources. Another thing is we want to really develop some more advanced features such as recommendations, machine capabilities, which we're working with the Neo4j to evaluate the Recon recommendation engine. And last is to incorporate other technology areas that we're working on, such as using Spark for high-throughput data analysis, using machine learning, deep learning, and also cloud technologies. To that extent, I'm very excited to come here to hear other people talk about how they use, how they combine those technologies together. Just to summarize our use cases here. So we're building our next generation technology intelligence platform using Neo4j graph database. We aim to capture complex data from a lot of different sources, including publications, patents, news media, etc., to create a coherent knowledge graph within Neo4j. And the objective and the goal of doing that is to help connect our scientists, engineering with external collaborators to deliver the most innovative solutions. With that, I just want to thank all the team members who has been working on this project at Dupont, as well as our colleagues at the Neo4j who has been helping us along the way. So, and also, thanks for your attention. I'll be happy to answer any questions.
With news media, do you extract anything from the articles and when you're ingesting those articles and to know things about them, or with any other, the patents and so forth? Are you extracting entities or other phrases or things from it?
Yes. Regarding news media, so we use some third-party data services to get very specifically targeted news articles with regard to specific company or brand. And we also apply some other third-party capabilities to extract entities, such as company names, product names, etc., from those entities. And eventually, we map all the entities into our graph database. We use a range of third-party services. Yeah.
So are you tracking how people are using the knowledge graphs? Are you trying to track experiences and how people use the knowledge graphs? Or are you just building the back end? And
That's a very good question. As I mentioned, we want to know how our users are using the graph, and also to capture their insight while they're using the graph. So that's a objective for the next step.
Any more questions?
Are you able to elaborate at all how you're doing the connection between Neo4j and like your business intelligence tools for the end user?
I'm sorry, can you repeat your question?
How are you basically getting all the data out of your graph database into your BI tools? I mean, my understanding is a lot of those BI tools don't have native connectors into graphical databases.
In terms of data ingestion, we have our customized data ingestion pipeline to do the data ingestion. For pulling data into other BI tools, again, we have to rely on a customized script to do the data transfer. To that end, I really hope that Neo4j can develop a solution that also do the BI analysis aspect.
Okay. Thank you very much.
All right, thank you.